Hello guys, welcome back to my YouTube channel, and my name is Dharyll from Bad State U. So for today's video, we're going to tackle about the packet tracer activity in the chapter 3 Internet ACAD. So this packet tracer activity, which entitled Investigating the TCP/IP and OSI models in action. So the objectives of this activity is part 1 to examine the HTTP web traffic, and part 2 display the elements of the TCP/IP protocol suite. So the background of this activity is the simulation activity is intended to provide a foundation for understanding the TCP/IP protocol suite and the relationship of the OSI model. Simulation mode allows you to review the data contents being sent across the network at each layer. As the data moves through the network, it is broken down into smaller pieces and identified so that the pieces can put back together when they arrive at the destination. Each piece is assigned a specific name, protocol data unit, PDU, and associated with a specific layer of the TCP/IP and OSI model. Packet Tracer is simulation mode enables you to view each of the layers of the associated PDU. The following steps lead the user through the process of requesting a web page from a web server by using the web browser application available on the client PC. Even though much of information displayed will be discussed in more detail later, this is an opportunity to explore the functionality of a packet tracer and will be able to visualize the encapsulation process. So part 1, examine the HTTP web traffic. So in part 1 of this activity, you will use the packet tracer PT simulation mode to generate the web traffic and examine HTTP. Step 1 is switch from the real-time to simulation mode. So in lower right corner of the packet tracer interface are tabs to toggle between real-time simulation mode. So we're going to click in the real-time mode, simulation mode rather. I will make this a bit large. Then always start in real-time mode, in which network protocols operate with a realistic timings. However, a powerful features of the packet tracer allows the user to stop time by switching the simulation mode. In simulation mode, packet tracer are displayed as animated envelopes, time and events driven, and the user can step through networking events. So click the simulation mode icon to switch from real-time mode to simulation mode. Select HTTP from the event list filter. So this is our event list filters. So as you can see, the visible events is already at HTTP. So click edit filters to display the available visible events. Edit filters, so display events. Then toggle the show all none checkbox and notice how the checkboxes switch from unchecked to check or check to uncheck depending on the current state. So when we click the show all, we will notice that all of the protocols in their box is checked, and when click again, it will be unchecked. So next is click the show all none checkbox until the box are all cleared. So we'll already done that. Click anywhere outside of the edit filters box to hide it. The visible event should now only display HTTP. So here we're going to choose HTTP. And as you can see in our event list visible events, it shows the HTTP. So we'll proceed to the next procedure with generate web HTTP traffic. So currently the simulation panel is empty. So this is our simulation panel. So it is divided into 5 columns and the event list. So as a traffic is generated and stepped through, event appear in the list. So the info column is used to inspect the contents of the particular events. So node. So first is click the web client in the left pane. So Here's our web client. Then we'll proceed to the desktop tab and then go to the web browser. And here we're going to type the web address www.osi.local. Then press enter. After that, in the URL, because the time in simulation mode is event driven, you must use the capture dash forward button to display the network events. So here, this is the capture event. So we're going to click it. Uh, how many times? There should be a 4 times event in the event list. So we should be able to make the 4 events here in our event list. So by doing that, we're just going to click 4 times. So 1. So there is only 2 events here. 2, 3, and 4. Next is look at the web browser page. Did anything change? So here is our web page. So there is a message here: you have successfully accessed the homepage for web server. So there is a change happened, which this dialog appeared. So next is explore the contents of the HTTP packet. Click the first colored square box under the event list info column. It may be necessary to expand the simulation panel or use the scroll bar directly below the event list. So first we're going to X this. So here is the first square box. So and the outbound PDU details, because this is the list of transmission as more events are examined. So there will be a 3 tabs display in adding a tab for inbound PDU details, which when event is last. So this is the last event. In the stream or traffic, only the OSI model and inbound PDU tabs are displayed. So as you can see, this is the OSI model tab and the outbound PDU detail. So ensure that the OSI model tab is selected under the out layers column. Ensure that the layer 7 box is highlighted. Excuse me, highlighted. So what information is listed in the number step directly? What is text displayed next to the 7 layer? So as you can see here in our simulation panel in event list, here is all of the type here protocol is the HTTP, and then next is what information is listed in the number steps directly below in the in layer and out layer boxes. So as you can see here in our first layer, the HTTP client send a HTTP request to the server. So next is click the next layer. Layer 4 should be highlighted. What is the destination port value? So next layer. So here the destination port value is 80. Then click the next layer, and layer 3 should be highlighted. What is the destination IP value? So this is the layer 3, and the destination IP value is destination IP is 192.168.1254. So click to the next layer again. What information is displayed at this layer? Excuse me. So the information displayed here in this layer is located here, which is the next hop IP address is a unicast. The ARP process look it up in the ARP table. The next hop IP address is in the ARP table. The ARP process sets the frame's destination MAC address to the one found in the table. The device encapsulates the PDU into the internet frame. So next is click the outbound PDU tab details. So here we proceed to the outbound PDU details. So information listed under the PDU details is reflective of the layers within the TCP. TCP or IP model. So what is the common information listed under the IP section of PDU details as compared to the information listed in the OSI model? With which layer is associated? So as you can see here, in the outbound PDU details, this is our source IP address. So with going back to the OSI model, our source IP address here is here 192.168.11. So the source is the same in the outbound PDU details. So this is our source. And also it is located here, the destination IP address. So going back to the OSI model, in the out layers, our destination IP address here is 192.168.1.254. So it is also the same here in the outbound PDU details, in the PDU format. Also, it is source port and destination port is also located here. So going back to the OSI model, here you will notice the source port is 1025 and the destination port is 80. Going back here, the source port is 1025 and the destination is 80, so it is also the same. And also here in the most in here below, you will see the host server web page is the one that we typed earlier. And next is what is the common information listed under the TCP PNAME? We already done that. What is the host listed under the HTTP? So the host is this. I already shown you the host. Then what layer would this information be associated? Associated with the OSI model tab. So the layer that should be associated here is the layer 2. And then click the next colored square box. Under the event list info column, only layer 1 is activate, not gray out. The device is moving from frame to frame. So we're going to click here the next. So as you can see here, in the out layers, only the layer 1 port is activated. So the device is moving the frame from the buffer and placing it to the network. So we're going to advance to the next checkbox. So here, this windows contains both in the layers. So this is the in layers and the out layers. So notice that the direction of the arrow is under the in layers. The in layers column in this point upward. This indicating that direction is the information is traveling upward. So scrolling through these layers, making notes of the items previously viewed. So at the top of the column, the arrow point to the right. So this denotes that the server is now sending the information back to the client. So it's just like a cycle. So the out layers will go the information here, and the in layers will pass it to the out layer. So it will just circulate like that. So comparing the information displayed in the layers column with that of that outer layer column, what are the major difference? So the major difference here is this. For example, is in the out layers, the source IP address here is 192.168.1.254, while the source IP address here in the layer 3 in the in layers, you will notice that it is 192.168.111. So they have the different source IP address. So also they have the different destination IP address. So here in out layers, the destination IP address is 192.168.1.1. So here in layers, the destination IP address here is different from the outliers, which is 192.168.1.254. So that is their no their major difference. So what happened here is the source IP address of the outliers is the destination IP address in the inlayers, while the destination IP address here in the inlayers is the IP source address in the outliers. So click the outbound PDU details tab and scroll down the HTTP section. So we're going to click the outbound tab and scroll. What is the first line in the HTTP message that display? I'm going to find that. So it's show here's the data connection close. So click the last colored squared box. So we're going back here. What is the first line in the HTTP message that display? So here it is, as you can see, data connection is closed. So click the last colored square box under the info column. So we're going to click the last box. Then how many tabs are displayed with this event? So there are two tabs here, as you can see. So part 2, display elements of the TCP and the /IP protocol suite. So in part of this activity, we'll use the packet tracer simulation mode to view the examine of some other protocols comprising of the TCP/IP suite. So view other step 1, view additional events. So close any open PDU information windows, and then in the event list visible event section, click show all. So where is the show all here? In the event list, visible show all. What additional event times are displayed? So as you can see here, so there's lots of event types that are listed. There are DNS, ARP, TCP, HTTP, TCP. So those are the different types that is displayed here. So this extra entires play various roles within the TCP and IP suite. If the address resolution protocol ARP is listed, it searches the MAC address and the DNS. The MAC address. DNS is responsible for converting names. For example, is Google.com and Cisco.com. They have their own respective IP address, so it should be unique. So the additional TCP event are the responsible for connecting or agreeing on communication parameters and disconnecting the communication session between the devices. So these protocols have been mentioned previously and will be further discussed as the courses progress. So currently there are over 35 possible protocols event types, so available for capture within the packet tracer. So click the first DNS event. The event in the column expose the OSI model and the PDU. In the PU tab, as you look at the OSI model tab with the layer 6 highlighted description, what is of what is occurring in this listed directly below in layers and out layers. The DNS client sent a DNS query to the DNS server. So this is very useful information to help understand what is occurring during the communication process. So here in the DNS layer 7 DNS, here is the UDP source. The source port is 125, and also it is indicated here the IP source address and the destination source address. So click the outbound PDU details tab. What information is listed in the name in the DNS query section. We're going to find here. Here is located is the name of the site or the web address is the www.osimodel.local. So click the last DNS info colored in the square box in the MS list, which is the device. So we're going to click the outbound PDU tab. Click the last DNS info. Oh, sorry. The last DNS info. Which device is this play? So the device displayed here should be the source IP address and the destination IP address. So find the first HTTP event. So the first HTTP event should be here, and click the colored square box of the TCP event. Find the first HTTP event and then corner box and of the TCP event, and immediately following this event, highlight the fourth layer of the size model tab in the numbered list directly below in the in layers and out layers. What is the information displayed under the items of layer 4 and layer 5? Layer 4 and layer 5. So here in the layer 4, it is indicated here that the TCP source port, which is 80, and the destination port is also located here. So layer 4 items and 4 and 5. No, that the TCP manager manages the connecting and the disconnecting of the communication channel along the with the other responsibilities. This particular event shows that the communication channel has been established. So click the last TCP event. The last TCP event, highlight the layer 4 as a model tab. Examine the step listed directly below in the layers and out layers. What is the purpose of this event based on the information provided? The last item should be 4. So first, in the first purpose of this event is fast Ethernet 0 receive the frame. Next is the frame's destination MAC address matches the receiving port's MAC address, the broadcast address, or the multicast address. The device encapsulates the PDU from the internet frame. So that's it. So that's the information which uh, purpose of this event based on the information provided in the last column. So that's it. So that's it for today's video. I hope you learned something, and if you like this video, please like, share, and subscribe. And thank you for watching, and bye bye.